In this section, we're going to look at multiple regression analysis using binary or dummy variables. To do this, we're going to use the regression tool in the data analysis toolpak in Excel. If you don't have the data analysis toolpak installed, in other words, if when you click on the data tab, you do not see data analysis here, you need to go to the File tab, select Options, then Add-ins. Then Excel add-ins is good, select Go, and then you need to select the Analysis Toolpak and say OK. Then you'll see data analysis appear here. We're going to use this data for this analysis. If you don't already have a worksheet with this data in it, you'll want to pause the video at this point and create a worksheet with selling price as Y, square footage as X of 1, age as X of 2, and the conditions as indicated here. Go ahead and pause the video and get your worksheet ready. In order to analyze this data set with dummy variables, we need to create columns for the dummy variables. So I'm going to insert two columns to the right of the age of the house. I'll highlight the D and E columns, right-click, select Insert. That will move those over two columns. Now I need to create two additional columns. You'll notice that I have three conditions. These are qualitative variables, and we have to turn them in to binary or dummy variables. This is a characteristic of the house. The condition of the house is present in every house. In this case, we've decided that the condition characteristic for houses are either good, excellent, or mint. So in order to use binary variables or dummy variables, we need to create two for the three conditions. You always have to assume that one of the conditions exists in the house. So there's a base condition of the house. To understand that, let's just assume that instead of square footage in that column listed, let's say that we created a binary condition for square footage. We decided that square footage would either be small, medium, or large. So for houses, they have a small amount of square footage, a medium amount, or a large amount of square footage. So if we were to create dummy variables for this, we would create, for example, a dummy variable for medium and a dummy variable for large. We would assume that small was the base condition, because if we created dummy variables for all three, small, medium, and large, then if we set them all to 0, we would have a house essentially with no square footage. But that's not possible. So the same way here with condition, if we set all of these up as binary variables, all three, we would assume that if we set each of those to 0, that there's a house that exists that doesn't have a condition. Well, that can't be the case. So we're going to just take two of these and set them up and assume a base condition for all houses. So I'll set up the excellent condition and the mint condition. Now, if I wanted to label these, I would go ahead and put X3 up here. And the reason I do this is so that I can use an if statement to check on the condition of the house. It's a little bit easier. Not such a big deal in this case where we only have three conditions, but in a situation where you have dozens, maybe hundreds of variables to define here, it's much easier if you can use an if statement where we say equals if, and then we look up to our condition for this column. And since this is row-wise data, so excellent, mint, and our conditions are laid out in rows, I'll use the F4 key to lock the row equals the condition. And since our conditions are listed in a column, I'll go ahead and lock the column. Then I'll put in a 1 to turn on the binary variable, otherwise a 0 to turn it off. When I press enter then, sure enough, that's good. Now I can copy this over because I used relative and absolute cell references correctly. This then looks to the right row for the condition and to the right column for the list of conditions for each house. And I could copy that across, type that equation one time, copy it across to all of my conditions. Now you'll see when I select these both and bring them down using the autofill node here, you can see that sure enough, here's my mint, here's my excellent, everything's working just fine. So now I've set up my conditions. All right, let's go ahead and check this. To do that, we will go up here to the Data tab and go over to Data Analysis, the toolpak that we installed. Then I'll scroll down to Regression. That's what I want, and say OK. Now I have my regression dialog box. It's asking me for the Y range, and I'm careful when I set up my model to make sure I identify each of the ranges so I don't get confused. We're using these X values to predict the selling price. The value that we're predicting, or the dependent variable, is Y. I'm going to select the label and the data. I get one row for a label. It makes it a little easier to read and understand the output. Then I'm going to select my X variables, and my X variables have to be contiguous. They have to be next to each other, because I'm going to select them all. I can have multiple X variables. I'm going to get all of them, and you'll notice that I took one row at the top to be the labels. Now I need to tell Excel that I included labels in my data, so I'll do that by checking this box. I'm going to go ahead and use the 95% confidence interval, so my alpha will be equal to 0.05 or 5%. If I wanted to change that, I could check this box and change it to 99 or to 90 or whatever. Now, I don't want my output to be on a different worksheet. I want to be able to look at this data while I look at my output. So I'm going to click Output Range so I can tell it where to put it. Now, Excel does a weird thing here. It moves its cursor back up here when you select Output Range. So you need to be careful. If you start typing now, you'll ruin your input for the Y range. You need to move your cursor down here and then select the output range. Then I'll say OK, and it will go ahead then and create my output. And here you can see we have data that we intend to use to predict selling price. Let's walk through these. I'm going to change these values to numbers so that they're a little bit easier to understand. Move them from scientific notation to numbers. Just make them that. And then I'm going to go ahead and do that down here as well. Have to give it some decimals here. Okay. Now let's talk about these values. First of all, it's important to remember that these values don't mean anything to us. The intercept, on the intercept row, we're just going to use the intercept coefficient. That's where the selling price crosses the y-axis. So that's where all the selling prices start. Then we have our coefficients for other values. So for each square foot, we increase the selling price by $56.42. For each year of age, we decrease it by $3,962.82. An excellent condition house increases the selling price by $33,162.60. A mint condition house increases the selling price by $47,369.20. Now, we're going to look at our correlation coefficient, our multiple R, and see that we have a strong positive correlation, 94% or 0.94. We'll look at the coefficient of determination, or R squared, and we have multiple X's, so we're going to look at the adjusted R square value, of 85% or 0.85. If we had only one x, we would use the R-square value. We'll look at the significance of each of our x variables here in the p-value. We have a alpha of 0.05. Remember, our confidence interval was 0.95 or 95%, and our alpha is 1 minus our confidence interval. The null hypothesis for correlation analysis is that R equals 0, that there is no correlation. So if the p-value is less than our alpha of 0.05, we're going to reject the null hypothesis and assume that there is a significant correlation. If it's greater than or equal to our alpha, we're going to fail to reject the null hypothesis and conclude that there is no significant correlation. But as we look down this list, we see that each of our x values has a p-value that's less than 0.05. Each of these x values then indicates a significant correlation. Our model as a whole indicates a significant correlation. It is well below our alpha value of 0.05. Now, if I wanted to forecast the selling price for a particular house, I could do that here. Let's say I wanted to forecast the selling price of a house with 2,000 square feet that was 13 years old in excellent condition. I would then set up my model by taking the intercept and adding to that the square footage times my square footage coefficient, slope, plus the age times my age coefficient, or the slope value for age, my excellent condition times my excellent condition coefficient, plus my mint condition times my mint condition coefficient. I would then forecast that the value of a house with these characteristics, the selling price, is about $216,160. Now, it's important to remember that in this type of model, I can only forecast or predict within the parameters of my model. So I couldn't forecast the selling price of a house with a square footage less than the smallest square footage in my model, which is about 1720, or more than the largest, which is about 3800. I couldn't forecast or predict the selling price of a house with age less than 12 years or more than 40 years, or with a condition other than good, excellent, or mint. So I have to, in these analyses, keep my forecasts within the parameters of my model. Now, if I wanted to forecast the price of a house in good condition, I would simply turn off excellent and mint. Here's good condition. If I wanted mint condition, I would just turn on mint and I would get the forecasted selling price of a house in mint condition. That's how you do multiple regression analysis with dummy variables.